internal audit reports. They are asking us to pay the EPF and ETF. Yes. Actually, we are not paying EPF, ETF for the risk, the persons, no.
Yeah.
But they are recommending that.
I see. Okay. So in that case, if it's 60,000, then we have to deduct the amount and give the rest to the RA.
Yeah, that we will like talk, madam, after.
Thank you, Ms. Verangi Perera. It was a real eye-opener, and I think the young academics now you know what to expect and whom to approach in case you want help. So thank you so very much, our senior assistant Bursa, I'm Verangi Perera, and I've been keeping the next speaker waiting for more than half an hour. I'm so sorry about that. So we have now it's an area that I really need help in, statistics. So the next speaker is Dr. Sameera Viswakula. He's the director of the Center for Data Science, Department of Statistics of our faculty. So he will be presenting on the importance of statistics in research, and more importantly, on how to get help. So over to you, Sameera.
Thank you, madam. Thank you for having me, and very good evening to everyone. I hope you can see my screen and hear me as well.
No, we can't. Yes, we do. Yes, Sameera, go ahead.
Okay. So the topic today is importance of statistics in research and how to get help. And I thought of covering these 5 aspects. So first of all, I'll be talking about the importance of statistics. Then some of us knowingly or unknowingly doing misusing statistics. I'll be showing some of the examples. Then I'll be giving a step-by-step guide to a statistical analysis. Then I'll be introducing some tools that we can use for statistical analysis. And lastly, I'll give some pointers to get help. So statistics, this term came from, it's a very old term. It came from Latin term statisticum and Italian word statista, and now we are using statistics. Previously, statisticians were called as statistics, this term, statistics, right? So that's a brief history. And so what is statistics? As most of you know, statistics is the science of collecting, analyzing, presenting, and interpreting data, according to Britannica Encyclopedia. So, originally, this term was associated mostly with the government data, with the census and etc., etc. Now we are using statistics for almost every field. I would like to share this quote by John Tukey. The best thing about being a statistician is that you get to play in everyone else's backyard. So we actually get invitation, collaborations, and we are people are asking help for statistics. So we actually we are playing in their backyards. So I thought of sharing some of my experiences as applications of statistics. So I'm in the business for like 10 years now. So these are some of my experiences. So I remember one of the undergraduates coming to me asking help to get a p-value, of course. So he was developing a new mosquito repellent. So he wanted to compare that with the existing ones, and he wanted to say that, okay, his repellent is better than the one in the market. So I'm telling some of the applications, the importance of statistics, right? So another example was germination of rice plants. So this researcher was also interested in applying statistics for their research. And so we actually found the optimum fertilizer level for these rice plants to get the best germination proportion. Then this is my master's work. Uh, I did some RNA analysis. I'm a statistician, but this is an application of statistics. So as some of you know, so there are these RNA secondary structures. They have certain patterns. We can predict them. I mean, we need to predict them to find, I mean, develop vaccines, etc., etc. So I actually came up with a distribution for occurrence of these palindromes. That is another example. Another one is my PhD thesis, where we predicted the DNA protein binding sites using NGS data. Another bioinformatics example. Recently, we had to forecast the number of dengue patients. A couple of years ago, we had a dengue epidemic. So we wanted to forecast the number of dengue patients. So using a time series modeling approach, we did that. And another example is this girl came from, she's an Ayurvedic researcher. She developed a new drug for the diabetes. And she wanted to show that her drug is not inferior to the one available from the Western medicine. So we did that as well. Recently, I had the chance to involve with the malaria research as well, where malaria transmission intensities were studied, and also forecasting financial indices like inflation, etc., etc., can also be modeled using statistics. So these are some of my experience. If you ask a senior person from our department, they would give a very lengthy list. Then I thought of sharing this quote as well. To consult the statistician after an experiment is finished is often merely to ask him to conduct a post-mortem examination, right? Most of the time, this is what happens, right? So they write the proposal, they get the grant, they collect the data, and just before writing the report or just before publishing, they call us. Most of the time, our friends call us. Sameera, my friends, workplace friends, daughter is doing this thing and we want to get some plots. That is how the discussion starts. But at the end of the day, they may want to do some modeling as well and get p-values, right? So as Professor Nalin said, we need to plan early. So right before writing the proposal, we need to get statisticians' help. Otherwise, we can't plan the study properly. So what we do is we do scientific research. So scientific research involves with scientific methods. So this is the one illustration of this scientific method. So we observe, we question, we research, we hypothesize, we experiment, then test the hypothesis, then we draw conclusions, and then we report the findings. So as you can see, for most of the areas, statistics is required in scientific methods, right? So that is why it is very important to get proper help, proper statisticians' help when you are planning or conducting the experiments, or basically when you are doing research. I want to emphasize two key issues addressed by data analysis. First one is statistical significance. So everybody is happy if we get a low p-value. So if it is less than 0.05, so we reject the null and everybody is happy. So it shows that there's an effect in the study. But at the same time, we need to check whether it is practically significant. Statistical significant is not, I mean, we should not stop there. We should check whether it is practically significant as well. For example, when the effect is large enough to be meaningful in the real world. For example, maybe, I'll talk about an example in a little while, maybe the next slide, right? What is meaningful may be subjective and may depend on the context. maybe your experimental results are statistically significant, but for real world, there's no use, right? So we have to check that um, before actually concluding or publishing. So statistical significant, as you know, it is denoted by the p-value. Practical significance is represented by the effect size. So the effect size, depending on the test, depending on the study, the formula changes, and there are certain guidelines to follow when you are referring to the effect size. Anyway, so with the statistical significance, we had to always look at the practical significance as well. That is basically look at the effect size after the p-value. So p-value, as we know, if it is less than, if it is a very small value, everybody is happy, it's highly significant. If it is borderline, we say it's okay, it's still significant, right? If it is 0.05, right? Okay, so we are in trouble. So let's redo the calculations. Okay, and so on and so on, right? Sometimes we interpret the way we want, right? So this is an example of the effect size. So this person is saying the employee satisfaction has doubled since last year, right? So it sounds good, right? Employee satisfaction has doubled since last year. But actually what happened was it got increased from 1% to 2%. So even though it's statistically significant, the practical significance is very less, right? That is what I'm saying. Do I have a question or something? All right. So the so this is an example. So researchers are studying a new weight loss program. Okay. So they are focusing on a weight loss program. So from the study, they have constructed, they got the results, they got the data. Then from the data, they have conducted a confidence interval, right? Constructed a confidence interval, 95% confidence interval. And they found that the confidence interval is 0.12 and 0.2. So here, the random variable of interest is the change in the weight or the weight loss, basically. And also when we are doing an experiment, the measurement of the variable is also very important. So by just looking at the confidence interval, we can't say anything. We should know, okay, how did they measure the weight? So in this case, they were measuring using pounds, right? So if you look at the confidence interval, 0 is not there. So if you know a little bit of statistics, then what this means is 0 is not there. So we reject the null hypothesis, which means this is significant. Or in other words, the weight loss program is statistically significant. So the weight loss after 6 months is statistically significant, right? But if you look at the values, it's 0.12 pounds and 0.20 pounds. So it's a fraction of pound, right? So there's no practical use of it, right? However, most people would say that the results are not practically significant because after 6 months, we should be expecting more, right? After 6 months of participating on a weight loss program, what's the point of losing a fraction of a pound, right? So these things matter, right? So not only the statistical significance, you have to always check for the practical significance as well. Then another very famous quote, lies, damn lies and statistics. So most people do not trust statistics because people have been misusing statistics. For example, on news, I saw that the rate of teenage pregnancy in a low conservative religious group, in a conservative religious group was higher than the national average, right? So in this religious group, the rate of teenage pregnancy was higher than the national average. But it's a conservative religious group. Sounds fishy, right? So actually what happened was, so they get married in a very young age. So they are still married, but there's no harm in the sense, nothing violated, right? It was due to the high percentage of women who got married while still in their teens, right? That is why the rate of teenage pregnancy is high than the national average, not because they are doing something bad, right? Okay. Then another news was giving conflicting claims about employment during presidential election campaign. So the opposition says the unemployment rate was going up, right? But the president's campaigners say the employment rate was going up, right? Actually, both of them were true. What happened was the population size has increased. So the number of people who were employed and the number of people who were unemployed had both increased, right? Because of that, the rates were high. So you need to look at the values, these numbers in a broader view, right? Before concluding. I would like to show some, some misleading, misuse of statistics, right? So here it's a misleading graph. Why? Because I have from data from average annual global temperatures from 1880 to 2015, right? Large amount of data plotted. X-axis goes from -10 to +110, right? Actually, this was coming from a report produced by a government. So government wanted to show that there's no global warming. It seems, right? Because it's a flat line. But if you enlarge it, if you zoom it, you can see that it's going up. Even a 1 or 2 degrees of increase in the temperature would affect a lot, would have a higher impact on the snow and the North Pole and the South Pole, right? So these things can be seen if you pay attention to the data. You need to use proper axis, proper scales, right? Since this talk was focused on the young staff, I thought of sharing this, right? So here again, I'm comparing 3 graphs. It seems like group A has a very high value, but when you're comparing, it's better to start from the 0. The y-axis should start from 0. That way you have the clear comparison. This is a better comparison than this one. Sometimes media channels do this, right? So here, what happened was the scale is disproportionate. So we are using a very high scale from 0 to 40. Whereas if you focus more on this area, you can see the fluctuations better, right? So in this case, so this is from Fox News, COVID-19 cases in the US, right? So what's wrong with this graph? Can anyone tell me? Is it a good graph?
No, I think the time axis is wrong.
Okay. Actually, yeah. Thanks for the answer. Time axis is okay, but if you look at the y-axis, this gap is 5, whereas this gap is 15, right? So they wanted to show this low number of COVID cases at the beginning of the pandemic, right? So they were using this scale from 0 to 5 here. Then they were using gaps of 15 after that. So this is wrong, right? So the corrected version would be like this, right? Then what's wrong with this plot? So biggest COVID-19 worries. Some media channel was asking, either you are getting it, or family getting it, or the economy. What's your most concern, right? So as you can see, the sum of the percentages are not 100% because this is a multiple answer question, right? So when a multiple answer question is there in your questionnaire, you cannot use a pie chart. It will be a misleading result. So a better option would be a bar chart, right? So here another example. In this case, the cherry picking data I'm using. if you focus only on like 3-4 months, you can see there's an upward trend, but the real picture is actually there's a downward trend, right? So we have to be careful when we are presenting data. Next, what I'm going to talk about is the step-by-step guide to statistical analysis, right? So loosely speaking, statistical analysis means investigating trends, patterns, and relationships using data, right? So there are several steps that we had to follow. There's an order, right? So we have to keep in mind that in order to draw valid conclusions, I mean, if you just conduct a study and do a analysis, and you can always get a conclusion. In order to trust these conclusions, we have to make sure that this analysis was correctly done. The assumptions were not violated. Data were collected properly. It's a representation sample of the population. There are so many things that we had to worry. Otherwise, we cannot trust the conclusions coming from the analysis. After collecting the sample data, what we usually do is we organize and summarize them. This is called descriptive statistics. Then what we do is we jump into the modeling part, hypothesis testing, modeling, that is called inferential statistics. Inferential statistics, what we do is we look at the sample data, and after doing some tests, we make inferences about the population, right? That is what we do in inferential statistics in a very short description, right? Finally, we interpret and generalize the findings. Okay. So first step is writing hypothesis and planning the research design. So we had to, as Professor Nalin said, we had to properly write down the research question. In statistical terminology, the hypothesis should be written properly. Otherwise, the entire analysis would be wrong, right? So, so most of the time, the goal of the research is often to investigate relationships between variables within the population. So most of the time in analysis, what we do is we investigate relationships between variables. Sometimes we make predictions, right? So for this, there are hypotheses, dedicated hypotheses for dedicated tests. So we had to use the proper test. We had to formulate the hypothesis properly, right? For example, if someone is claiming that the average income of academics in state universities is rupees 105,000, right? So how would I test this? I should take a representative sample, right? And do a proper test. So first of all, I have to write down the hypothesis. So when I'm talking about a hypothesis, there are two parts, null and the alternative. So I had to write the null and the alternative properly. So these are little things, but when you look at the broad picture, when you come to the end of the analysis, if these things are wrong, your entire analysis is wrong. So you need to pay attention and spend some time on this, right? Then you need to plan the research very carefully. There are several research designs available. So we need to pick the one that suits more for our study. For example, there are experimental designs, correlational designs. Experimental design is like this. So if you want to assess the cause and effect relationship, this would be the ideal case. If you want to explore the relationships between variables, then a correlation design would be better. Likewise, there are several designs. I'm going to speed this up, otherwise this will be a statistic lecture, right? So case study design, causal design, cohort design, cross-sectional design, exploratory design, longitudinal. Likewise, there are many designs. So you need to consult a statistician before writing the proposal, right? Pick the best the design for you and go from there, right? When planning that experiment, we need to decide exactly how we are going to measure the variable. So the levels of measurement, I mean, what are the variables we'll be collecting? What are the units? Are they nominal? Are they interval? Are they categorical variables? Are they quantitative variables? All these things are important. Otherwise, the test you are going to use sometime later won't fit into this data, right? So sometimes we had to transform data and maybe we had to recode the data, but we had to be careful. For example, if I record the ages as children, youth, adult, and seniors, and if I code them as 1, 2, 3, 4 in a data set, this is what I would be seeing. Maybe later on I'll be finding the average of this, right? Which is not meaningful. So you have to be very careful when you're dealing with data. Collect data from samples. As we know, sometimes it's practical, not practical, sometimes it's very expensive, sometimes it's very difficult to reach the entire population. So what we do is we take samples. So there are various sampling methods available in statistics, right? Some of the terminology we use in sampling is survey. Survey is when we are collecting data from a sample. Census means when we are collecting data from the population. Likewise, there are some terminology available. There are two main types of sampling available: probability sampling and non-probability sampling. In probability sampling, this allows random selection. We are selecting individuals from the population to the sample randomly. Non-probability means there are several other criteria. Most of the time, it is very convenient. For example, if I want to select 100 students, what I do is I go to the open canteen and I'll be waiting at the door, and I'll be selecting the first 100 students coming to the open canteen. It's a convenient sampling, but it's a non-probability sampling technique. Likewise, there are various sampling methods available. So the usual practice is we use parametric tests for probability sampling. When we are doing a probability sampling method, the test we should be using should be parametric. If we use non-probability sampling methods, usually better option would be non-parametric test. I mean, there are some things that we can do to change these tests as well, but this is the usual practice. So what I'm trying to say is all these things are connected. If you do not select the sample properly, if you do not select the research design properly, the rest of the story will be wrong, right? So these are some of the probability and non-probability sampling techniques. Then sample size calculation, very important thing. So most of the time people take 130 or 272 or 180, some known values as the sample size, but it's not that good. So you should always consult a qualified statistician before deciding on the sample size. Of course, there are online sample size calculators available, but they might ask certain things. If you are not so sure about these terms, then don't use them, right? Otherwise, when you are going to publish them or when you are trying to sell your work, you will be in trouble. So you should know, before starting this study, you should know how you are going to select the sample and all. You have to plan everything, right? Then step 3 is summarizing your data with descriptive statistics. So usually these are the things we use. These are the tools, I may say, we use to describe data: frequency distribution, bar charts, pie charts, etc., etc. Then we look at the mean, mode, median. Those are the measures of central tendency. Then we look at the measures of variability, right? Then we come to some complicated work, that is hypothesis testing and inferential statistics. So estimation is twofold: point estimation and interval estimation. And inferences, we can do inferences using estimation and also using hypothesis testing. So I'm just touching upon giving the names just to be familiarized with these things, so that you know, okay, these things are there. I cannot blindly use statistical test, right? So these are some of the statistical tests available: comparison tests, regression tests, and correlation tests, right? So if you want to compare two samples, a comparison test would be fine. If you want to look at the or model relationship between two variables, you have to go for a regression test, right? Etc., etc., right? So the choice of statistical test depends on the research question, research design, sampling method, data, your data, and so many factors, right? So you have to consider all these things when you are deciding on the statistical test. So when it comes to statistical tests, there are two types of tests: parametric test and non-parametric test. Parametric tests are powerful, and on the downside, there are so many assumptions. If the assumptions are not met, don't use those tests. Go for maybe try transforming data, and or maybe you can go for non-parametric tests. Likewise, there are some remedies that we can do. I'm just listing out some statistical tests. So if the response variable is continuous, we can use regression. If it is binary, we can use logistic regression. If it has more than 2, we can go for multinomial, right? If you are comparing 2 paired samples, we use a paired t-test. Likewise, there are so many tests available. You have to pick the correct one for your study, right? So these are some non-parametric tests available. Spearman's rank correlation, chi-square test, sign test. So this Kruskal-Wallis test is, I'm pretty sure most of you are familiar with the ANOVA. So this is the non-parametric version of the ANOVA. Likewise, there are, when the assumptions fail, we can go for these non-parametric tests, right? Then the most important thing is interpreting the result. So the final step is the interpretation, right? So I'm giving an example here. Here the null hypothesis, a 5-minute meditation exercise will have no effect on math test scores, right? So we are trying to see whether a 5-minute meditation exercise has an effect or not. Whereas the alternative is it would improve the math score, right? So the p-value was 0.0027, so we are rejecting the null, right? So this is how we should be reporting the conclusion. Since your p-value is lower, you decide to reject the null hypothesis, and you consider your results statistically significant. This means that you believe the meditation intervention rather than random factors directly cause the increase in test scores. So you need to carefully write down the hypothesis. I think I have already taken 30 minutes, but I'll speed it up. So like I said, you need to be very careful when you are dealing with statistical tests. Not only the statistical significance, you have to carefully look at the practical significance as well. That is done by the effect size. Most of the time, we have to report the effect size along with the p-value. In APS style, it is a must, right? So these are some of the tools we use. We all have access to Microsoft Office 360. We can download them from the university website. It's free. So we can go to the options and ask for this analysis tool pack. Then it would give us this data analysis menu. It would give you some more statistical tests than what we see in the typical Excel, right? The other one, my favorite is R and R Studio, right? So it has this markdown as well. It is similar to LaTeX. So nowadays some research papers, they are giving the markdown template as well. So you can do the analysis from R and write the paper as well from R, right? Then if you do not like coding, you can go to R command. It has these menus, right? And there are some license software like SPSS, Minitab. We have this PSP. It is very similar to SPSS, but it's free. And some SPSS functions are available. And Python, again, free, but it needs some learning, right? So what is your favorite statistical software? Okay, maybe SPSS or maybe R, right? Right? Okay, so how to get help? So this is not in any order, right? So we can always search on the web, and we can check some YouTube videos, but we need to trust on them. I mean, we need to check whether those are trustable or not, right? And you can always go to MOOCs like Coursera or edX, right? I think the easy option is to consult a statistician. Then you can have a discussion. Then when you want to learn more about anything, you can do all these things. Let's say statistician recommends, okay, you should go for a 2-way ANOVA, right? So you can go to a YouTube video and look for a to know how it works and all this, right? So first thing is to consult a statistician. So you can always consult our department, right? We have talented, beautiful people, right? So you can contact us, right? Also, if you have any data science needs, we have the Center for Data Science. We have customized training programs also. For example, R for biologists, R for nursing people, likewise, or we can give Python. We have short training programs. Also, we do collaborative research, and also we do consultancy, right? So now you know what to do when you are stuck in your statistical analysis, right? And these are some of the references I use. And thank you. Sorry, madam, for going beyond the time.
No, thank you so much. Thank you very, very much. It was eye-opener. I was guilty of so many things that you said. So anyway, the young ones, when they're starting, they can start properly. And of course, I have to say that I have been working with the statistics department recently with Sameera, of course, and also with Rasika. And it has been a very, very pleasant experience. So I think people shouldn't suffer alone, and so go for help. So thank you once again, Sameera. Thank you very much. And I'm sure you will have lots of requests for help. And I hope you will come
Okay,
back.
okay. Thank you, madam.
Okay, thank you. Right. I deeply apologize to the next speaker, Dr. Kaumal.